So you may have noticed tanks of crawfish in the back of the physiology lab before you left town. Well, we put crawfish from Louisiana, these are Procamberus clarki, in a bunch of different tanks, and we added different amounts of sea salt to the tanks. So they're all at different salinities. And our goal is to find out if they're osmoregulating or osmoconforming in those different salinities. So now we take a water sample right next to a crawfish in each tank, and we take the crawfish out of the tank. Of course, we weigh them first because that's what physiologists do. And here's one crawfish. This is a male. You can see because he's got legs right here at the first abdominal segment. They're called pleopods that are relatively thick, like the legs he has to walk on. I'll show you what a female looks like in just a minute. Take a hemolymph sample at the base of the leg, from the base of the leg, I should say, for each of these guys. You only need a tiny bit of fluid to put in our vapor pressure osmometer, which we do over here. We get a small sample. Put a paper disc inside the osmometer. Put our hemolymph sample inside. Close it up, and it will tell us what the osmolarity was. We'll do the same thing with the water sample that we took from the same spot. Now here's what a female looks like. See, she's got soft and feathery appendages on her abdomen here. Now how can we determine if they're regulators or conformers? Well, if our null hypothesis is that the concentration of their hemolymph is the same as the concentration of the water that they're in, we're testing the hypothesis that they're osmoconformers. We're going to do it differently for each tank. So we're going to recreate the figure that I put up on the board that I showed you at the beginning of this pre-lab talk, and you're going to have a cloud of points for each of the tanks. Now we're going to use data that we collected last year because we had a bunch of students to take all that data. And you're going to do a paired t-test for each tank to determine if the crawfish in that tank have hemolymph that's not significantly different. Okay, there's our number. 528 millimoles per kilogram, or milliosmoles per kilogram, is what the osmolarity was for the hemolymph of that crawfish. So we're going to compare that to what the tank water was, and if there's no significant difference from that paired t-test, then we'll assume they were conformers. But if there is a significant difference, we'll assume that they were not the same, and therefore it was osmoregulating. So they may show an osmoconforming strategy across the spectrum of tanks that we put them in. They may regulate, or they could show a mixed strategy, which is common in animals that live in estuaries, where they osmoregulate at low ambient osmolarities and they osmoconform at high ambient osmolarities. So I'll post the data and you all can make your own analysis and do the homework assignment.